Let's talk about the constitutional isomers of C5H11Cl. Let us first determine the degree of unsaturation for this elemental composition. We know that degree of unsaturation for this elemental composition will be number of carbon atoms plus 1 minus number of halogen atoms. So, here chlorine, so that is 1 by 2 minus number of hydrogen atoms by 2. So, we have 11 hydrogen atoms and we have 5 carbon atoms. So, 5 plus 1 6, 6 minus 1 by 2 minus 11 by 2. Let us take 2 as common factor. So, in this case it becomes 12 minus 1 minus 11. So, everything becomes 0. So, the degree of unsaturation here is 0, which means that we will not have double bonds or rings. So, it is a completely saturated elemental composition. So, let us write down the isomers one by one. 1, 2, 3, 4, 5 and then the carbon chlorine bond. Okay. So, let us do the numbering also. So, this is 1, 2, 3, 4, 5. So, we can definitely write 1 chloro pentane, yeah, and then we can also write 2 chloropentane, yeah, 2 chloropentane. Let us do the numbering 1, 2, 3, 4, 5. We can also write 3 chloropentane 1, 2, 3, 4, 5. So, let us write the chlorine atom at the third position. So, this is 1, this is 2, this is 3, this is 4, this is 5, this is 3 chloropentane. We cannot write 4 chloropentane because that will become 2 chloropentane. So, we are exhausted with the pentane chain. So, let us go to the butane chain. So, our fourth isomer will be 1, 2, 3, 4 and then write down the chlorine. So, we have 1 chloro 2 methyl butane. Not 2 chloro, this is 1 chloro. Okay. This is 1 chloro 2 methyl butane, because in alphabetical order chlorine comes first compared to methyl. So, we have to write on the chloro substituent first. So, 1, 2, 3, 4. We can also write 1 chloro 3 methyl butane. 1, 2, 3, 4 and then the carbon chlorine bond and then 1 methyl group at 3 position. Yeah. 1, 2, 3, 4. So, we have 1 chloro 3-methyl butane. We can also write 2-chloro 3-methyl butane. 1, 2, 3. So 2-chloro 3-methyl. Let's do the numbering. 1, 2, 3, 4. So we have 2-chloro 3-methyl butane. If you number it on the other way around, you might think that we can number it on the other way around. We should not do that, because we have to get the low priority for the chlorine as per the alphabetical order, because if you number it on the other way around, the substituents are once again getting 2 and 3. So whether you number it in the forward direction or reverse direction, the numbering of the substituents will be 2 and 3. Okay, so that's why we are not doing it that way. So when you have a tie like this, then you need to number it based on the alphabetical order. Okay, let's go to the 7th one. One, 2, 3, 4. So we can also write 2-chloro 2-methyl. 1, 2, 3, 4. So this is 2-chloro 2-methyl butane. So we are basically exhausted with the butane chain also now. Okay, we cannot put 2-chloro 2-methyl on the third position, because then if we count it on the, if we number it in the forward direction, that will become the same as 2-chloro 2-methyl butane. Okay, so let's go to the propane chain. So we can also write an isomer like this. So this is 1, 2, 3. So we have 1-chloro 2, 2 dimethyl propane. Okay, so these are the 8 isomers that are possible for C5H11Cl. Now let's see how the isomerism works out among these 8 isomers. 1 and 2 are position isomers. Yeah, 1 and 2 are position isomers. Let's put it as Pi. And what else is position isomers? So let's go to that. 1 and 2 are position isomers. 2 and 3 are also position isomers. 1 and 3 are also position isomers. So let's write down that. 1 and 3 as well as 2 and 3. All of them are position isomers. Yeah. How about the fourth one? Fourth one, if we are comparing the fourth one with the fifth one, then we once again have position isomers due to the methyl group this time. So 4 and 5 are also position isomers. Yeah, 4 and 5 are position isomers. How about 5 and 6? 5 and 6 are also position isomers. Yeah, 5 and 6 position isomers. Yeah, 5 and 6 due to the chlorine. Okay. Now, how about 4 and 7? 4 and 7 are also position isomers. Yeah, 4 and 7 are also position isomers. What else we are missing? How about 4 and 6? Did we count that? We did not. So 4 and 6 are also position isomers due to the chlorine as well as due to the methyl group. Okay. So 4 and 6 are also position isomers. Okay. Did we miss anything else? How about 4 and 7? 4 and 7 are also that position isomers that we already counted. How about 5 and 7? 5 and 7 are position isomers due to both methyl group as well as chlorine. Yeah, 5 and 7 are also position isomers. How about 6 and 7? How about 6 and 7? 6 and 7 are also position isomers due to the methyl group. So 6 and 7 are also position isomers. So we accounted all the position isomers. Now let us look at the chain isomerism. So for chain isomerism, if we are comparing 1, 2, 3, 4, if we are comparing 1, 2, 3 with 4, R5, R6, R7. So any comparison of 1 to 3, any comparison of 1 to 3 with 4 or 5 or 6 or 7 or even 8, then you are talking about chain isomerism. Okay. Any comparison of 1, 2 and 3 with 4, 5, 6, 7 or 8. Okay, any comparison of 1 to 3 with 4, 5, 6, 7 or 8 is chain isomerism, because in 1 to 3 you have 5 carbon chain, whereas in 4, 5, 6, 7 you have a 4 carbon chain, in 8 you have a 3 carbon chain. So those are the chain isomerism that are possible. Even if you are comparing 4, 5, 6, 7 with the 8, 4, 5, 4, 5, 6, 7 with the 8 is also chain isomerism. So only two kinds of isomers are possible. One is the position isomerism and another is the chain isomerism. If you do like this video, subscribe it to Chem Media. Thank you.